This JavaScript code demonstrates the implementation of basic CRUD, create, read, update, delete, operations on Firebase Firestore, a NoSQL cloud database, using asynchronous methods. It starts by initializing Firebase using the provided configuration object Firebase config, which contains keys and identifiers necessary to connect the web app with the Firebase project. After initialization with Firebase.initializeApp, Firebase config, and enabling Firebase Analytics, the Firestore database instance is stored in the variable CloudDB. Several HTML elements are fetched using document.getElementById to capture user input for student data fields like name, roll number, section, and gender. The update function dynamically updates local JavaScript variables, namev, rollv, secv, genv, based on the type of input received. The add_doc_with_AutoID function inserts a new document into the student's collection with auto-generated document IDs using clouddb.collection, students.add, and logs the new document's ID upon success. In contrast, add_doc_with_ID uses the roll number as a custom document ID by calling doc_rollv.set, ensuring each roll number is a unique document ID. The update_fields_in document function modifies only specific fields of an existing document, excluding the roll number, using the update method on the document identified by rollv, allowing partial updates. The delete document function removes a student record using delete on the document ID matching rollv. Each operation is asynchronous and returns a promise, with .then used to handle successful completions and .catch to handle errors, logging the results to the console. Button elements, insert btn, select btn, update btn, delete btn, are assigned on-click event handlers to trigger the corresponding Firestore operations based on user interaction, allowing dynamic manipulation of student records through a front-end interface. Overall, this code efficiently demonstrates asynchronous communication with Firebase Firestore using modern JavaScript, providing a full-stack mini-application capable of managing student data in real time using a web interface. This HTML document is a complete web-based form interface that integrates with Google Cloud Firestore using JavaScript to perform CRUD, create, read, update, delete, operations on student data stored in a Firestore database. It provides a front-end form for users to input student information such as name, roll number, section, and gender, and uses JavaScript event listeners to trigger interactions with Firestore on button clicks. The layout and styling of the page are managed using internal CSS, which gives the form a clean and modern look with centered alignment, subtle box shadows, rounded input boxes, and Google-style animated buttons. The page begins with a doc-type declaration and sets up a basic HTML document structure. In the head, the style tag defines styling rules that ensure a consistent and user-friendly interface. Key UI elements include the .contact container, which holds all form elements, styled with background, azure, padding, shadows, and border radius to create a card-like appearance, while input elements are styled for focus effects, transitions, and accessibility. Each input element is paired with a label inside a .input group container to enhance visual grouping. The form consists of 4 inputs: name, roll no, section, and gender, each linked to a function called update, value, type, which captures the user input and stores it in JavaScript variables like namev, rollv, secv, and genv respectively. These variables are used when performing operations on the Firestore database. Below the input fields are 4 buttons: insert, select, update, and delete, each with corresponding IDs: insert btn, select btn, update btn, delete btn. These buttons, when clicked, invoke specific functions defined in an external JavaScript file, dataedit.js, that was included at the end of the HTML body. The script imports Firebase SDKs, version 8.6.8, including Firebase App, Firebase Analytics, Firebase Database, Firebase Firestore, Firebase Messaging, Firebase Functions, and Firebase Storage, though in this context the main operations are only performed through Firestore. The dataedit.js script defines a Firebase config object containing the project's API key, domain, project ID, storage bucket, sender ID, app ID, and measurement ID, and uses it to initialize Firebase with Firebase.initializeApp, Firebase config, and enable analytics. It also initializes Firestore by creating a reference CloudDB equals Firebase.Firestore. The update function takes the input value and its type and assigns it to the appropriate variable. The insert button is tied to the add_doc_with_AutoID function, which creates a new document inside the student's collection with a randomly generated document ID and fields such as name of STD, roll no, section, and gender. The select button runs add_doc_with_ID, which creates a document with a specific ID matching the roll number, enabling the record to be uniquely identified. The update button triggers update_fields_in-document, which updates the fields of the document with the ID equal to the provided roll number but doesn't alter the roll number itself. This is useful for modifying name, gender, or section without changing the document ID. The delete button calls delete document, which removes the student document with the roll number ID from the collection. All these functions use Firestore's asynchronous promise-based methods, .then, and .catch, to handle successful operations and errors, logging the result to the browser console. Overall, this application provides a simple but functional UI for real-time data interaction with Firestore using client-side JavaScript, ideal for small web projects or learning-based applications. The design ensures usability with smooth transitions, intuitive labels, and error-free interactions. Additionally, because the Firestore SDK is directly imported from Firebase's CDN, the application requires no back-end server to work, everything runs in the browser. This front-end-based architecture leverages Firebase's serverless model, reducing development time while maintaining scalability. The Firestore database provides real-time updates, though this specific code does not implement real-time listeners or document fetching. It focuses on writing, updating, and deleting operations. In a production system, additional features like authentication, data validation, and security rules would be critical to protect and manage user data effectively. However, as an educational or prototyping tool, this implementation showcases how to perform key Firestore interactions through a styled, interactive, and responsive form, enabling users to practice essential full-stack skills like front-end design, client-side logic, and cloud database integration with minimal setup and maximum clarity. If you have any kinds of problem to execute this code or any problem you are facing to run with Firebase installation or initialize the application, talk to us directly or provide your contact details. Good to see you soon with another problem.